Hi guys, welcome back to my channel Pirai Academy. In this series of data structure playlist, today we are going to see about array ADTs implementation. So in previous video itself, I have told you that array basics. In that there is a operations, right? The array operations. So what are all the operations we can do in the array? Insertion, deletion, searching, accessing and traversing, right? Now in this video we are going to implement them both logically as well as in code. Okay, fine. So initially let me take an array of size 5. Assume the user wants the array of size 5, and let us in the upcoming we can implement all the functionalities. Okay, fine. So initially there will be an array of size 5. So 0 1 2 3 4. Fine. Now at first let me take insert at the index called 0, of for example the element called 5. So I will be inserting an element 5 at the 0th index. Can you understand this? Yes. So it is so simple. Now insert at the element 10 at 1, index 1. So it is also so simple. You can directly go and insert it. Now insert at index 2, insert some element like 7. Okay, now also you can directly go and insert it. But now comes the twist. Insert element, the value going to be 8, and insert it at the index number called 0. What you are going to do now? So it is going to be the critical, right? So as of now, I know that the size of the array is 3. Now the simple method I am going to use is I just start from here. And I make this 7 to come here. So which means I am going to start from size, which means I am going to start from index number 3. The size is also equal to 3, right? So I am going to start here and make this 7 to come here. Again go here. Make this 10 to come here. Again go here. Make this 5 to come here. Now stop. Now we have a vacancy on the index number 0, right? So now go and insert 8. That's it. Can I understand the insertion operation, right? So insertion means we are going to start from size up to the position. Okay, which means from size up to my iterator. My iterator going to be greater than the position. Okay, I'm going to up to the iterator greater than the position, and then I'll be just making that position index value as the given value. Can you understand this? Okay, so this is going to be the insertion. Now let's talk about the deletion. Now let me tell you that deletion of some index number 2. What will you do? So 2 means this 10 should be deleted, right? So which means instead of this 10 I want this 7 to be here, right? Can I understand this? Yes. So what I'm going to do is simply let me change the color. So simply I'm going to start from here. and make my next element to come in front of me up to the size. Now the size is going to be 4, right? Now my size is going to be 4. So which means I want to go up to the size. Okay, up to here. That's it. Okay, so I'll be just taking this 7 and making this 7 to come here. Can I understand this? Now I'll be making my size as 3. That's it. So now my array elements will be 8, 5 and 7. Because the size is only of 3, which means I only take these 3 elements, not this 7. But this 7 exists, but I will not take it. Can you understand this? Okay. Now let me take again. What are those 3 elements? 8, 5, 7, again 7, and then an empty. So 0th index, first index, second index, third index, and fourth index. Now let us go with the searching. Now I am going to search for example 6. Okay, first of all I will be starting from 0 up to the size. Okay, now whether this 8 is equal to 6? No. Okay, move on. Whether this 5 is equal to 6, no, move on. Whether this 7 is equal to 6, no, move on. But we already traverse up to 3 values, which means the size is also 3, right? The size is also 3. So don't worry, we will be returning -1 because the search element is not found. Can you understand this? If I am going with search of, for example, 5. First of all, I will be searching from the start point. So whether this 8 is equal to 5, no. Now whether this 5 is equal to 5, yes, which means I will be returning the index value. So what is the index value? Which is going to be 1. That's it. Can I understand this? Okay. So this is going to be the searching. And now accessing. Accessing means they will be giving some index. Okay. And we are going to return that particular index. So that's going to be simple. Okay. We can directly see that in the code itself. So traverse. Traverse means we are going to start from 0. My iterator going to be starting from 0 up to what? Up to the size. And I am going to print all the values at these particular indices. That's it. So this is going to be a traverse. Now let's see about the edge cases. Okay, for insertion, let me write here. For insertion, where we can insert an element. We can insert an element if the array is not full. Array is not full. Next step. When we can insert an element, if the given position should be in a range of 0 up to the size, then we can insert it. Can I understand this? Yes. Which means if there are only 3 elements, I can insert at the third index. Like that. Okay. So these are the conditions for the insertion. Now let's go for the deletion. What are all the conditions for the deletion? For deletion, the position should be from 0 up to the size -1. Can I understand this? So this bracket going to be the inclusive bracket. Okay. I don't know what is the representation, but heads up now, it is going to be inclusive. This interval going to be inclusive, not exclusive. Okay. So this is going to be the deletion condition. Now next, searching. For searching, there is no conditions like that. Now for accessing also, the condition should be position should be at the range of 0 up to size -1. And then for traverse also, there is only one condition. What is the condition is, if the array is empty, then what should I do? I should be displaying this message, the array is empty. How I am going to do this? I just check whether the size of the array is equal to 0. Then I am going to print this. That's it. Okay. Now let's see the time complexity for each and everything. So first of all, insertion. For insertion, the time complexity may be go up to the O of n. Why it's going up to this? Because we are going to shift each and everything. For example, the array is of total capacity -1, which means if the array of size 5, but there are 4 elements, I am going to insert at the 0th position, then I want to shift for n-1 steps, which means the time complexity going to be n. Okay, for deletion also similarly, time complexity going to be O of n. Okay, for accessing, it is going to be time complexity O of 1. And then for traverse, the time complexity is going to be O of n. And then for searching, let me write here. For searching, the time complexity going to be O of n, because it is going to be the linear search. I am going to search one by one. Okay. In the worst time complexity, it can be O of n. Okay. So this is going to be the time complexity, and overall the space complexity is going to be O of n, the user given capacity, the n number of elements. So this is going to be the time and space complexity analysis. Now let's jump into the code so that you can understand this in a better way. Till now, if you cannot understand the logic, now you can understand it. Okay. So see here, I am going to take in a C++ code. If you want a Java or Python code, you can go and search in the description. I will be giving that in description. Now see here. First of all, I am taking a class of array ADT. Inside this class, I am going to do these steps or do these functionalities. Okay, in private, I'm going to declare the array and capacity and size. This capacity going to be the what is the maximum capacity, and the size going to be the current number of elements. Okay. Now in public, I am going to I'm going with the constructor and the destructor first. Okay. So in the constructor, I am going to get the capacity as the parameter and going to initialize the capacity first. Okay, and then the size is going to be 0, and the array is initialized here with respect to the capacity given by the user. Now here comes the destructor. In the destructor, I am going to delete that array. That's it. Now comes the insertion. This insert function, I will be getting two parameters. One is position, another one is value. Now if the capacity is equal to the size, okay, these both are equal, then what I am going to say, it is the array is full, so cannot be inserted like that. Okay. Now if the position is less than 0 or position is greater than the size, then I can directly tell that it is an invalid position. If these two conditions are not satisfied, now the control flow comes here. So here I will just traversing from size up to the position, not to the position, up to the position, and then I'll be just making my my previous values to the current value, which means ARR of I is equal to ARR of I minus 1. Can I understand this? I'm going to shift by one place towards the right side. Okay. Now array of position is equal to value and size plus plus, and I'm going to print the inserted value and its position. That's it. Now the deletion. In the deletion, I'm going to get the position. If the position is not valid, I'm going to print that it is a not valid. And then here comes, I'm just taking the deleted value at first, because after deletion the value is vanished, right? So first itself I'm taking this and storing in a deleter. Okay. Now I'm going with the position up to the size minus 1, and I'm going to shift all them in a left side. Okay, in this entire loop. Next I will be just decrementing my size by 1, and then I'm going to print the deleted element. That's it. You understand this? Yes. Okay. Now here comes the accessing. In the accessing, I want the index to be accessed. Now I'm just checking whether that index is a valid index or not. Okay, if it is invalid, then that's it. I can just give that minus 1. Okay, else I want to return that particular index value. Now in the search, I want to get the value to be searched, and I want to go along with the all elements in the array and check whether the particular element given by the user is equal to the existing array value. If it is so, I will be returning that index. If not, I will be returning the minus 1. Okay. Now in this display, it is what? Traversing. Okay. So here I want to check whether the array is empty or not. If it is empty, then I want to just give as a array is empty. If it is not, the control flow comes here, and I will be traversing along from 0 up to the size, and I will be printing all the elements at the particular indices in the range. Okay. And then here comes the additional functionality, the get size. If there is a call for the get size, then I will be returning the total size of the array. That's it. Okay. So here comes the menu driven program. So overall code will be that's it. Okay. If you want the Java or Python code, you can go and find in the description, or you can try this by yourself itself. It is so simple. That's the reason why I am not giving you a detailed explanation. Okay. So that's it for the array ADTs. If you really like this video and subscribe to my channel. Don't skip any videos in this playlist, because all videos will be helpful once you are going with the problem solving. And if you have any doubts, you can just comment below. I'll be commenting in the comment section itself, or I will be giving you a separate videos. Thank you.